Hello, my name is Andrew and I'll be explaining number 6 on the group work number 1. So basically in this equation you're given x is equal to cosine t plus natural log of tangent t over 2 and y is equal to sine t. And what you want to do with this is you want to put it into the formula to find the length of the arc. So you're going to have the equation, the integral of b and then alpha beta, and then the square root of the derivative of x squared plus the derivative of y squared, and then just times dt. So the first thing you want to do is you want to find the derivative of x, and this takes the majority of the problem. What you're given is dx, well, you're just finding the derivative of the x equation, and the x equation, you can simplify it by, you can say, well, I'll take the derivative of cosine t, and then I want to find the derivative of the second part that you're adding. So derivative of cosine, really easy, is just negative sine t. And then the derivative of natural log tan t over 2, that's going to be a little bit more difficult, so you're going to have to use substitution. So I substituted with g, and g is going to be equal to tan with t over 2. And then by doing this, you can find derivative of natural log g, which you know is going to be 1 over g, because that's a basic derivative. And then you're going to be multiplying that by the derivative of tan over t over 2. So then you're going to get negative sine t plus 1 over g times secant squared t over 2 times 1/2. And you know secant squared t over 2 times 1/2 because that's kind of also another basic derivative that you would need to know from like Calc 1 or Calc 2. And then you're going to substitute g back in, which is sine t over 2, and then you can expand tangent, which is the g. So tangent's sine over cos, so you can simply say 1 over sine over cos with t over 2 on the inside of both of those. And then you can rearrange this. So 1 over sine t over 2 over cosine t over 2 can be arranged to cosine t over 2 on top of sine t over 2. Just kind of basic algebra stuff again. And from here, you can cancel out a cosine, so the cosine on top, and then you can get negative sine t plus 1 over 2 sine t over 2 cosine t over 2. And then when you see 2 sine and then like basically x or whatever's on the inside, and then cosine, you know that's another trig identity, and that's really important. So what you can do here is you can say negative sine t plus 1 over sine, and this is where the trig identity comes in handy, 2 times t over 2. So then you get negative sine t plus 1 over sine t. And this can be further expanded by multiplying this by sine t, because you want to be able to add these two, so you want to make this one into a fraction. So by multiplying that by sine t over sine t, you can basically get negative sine t squared over sine t plus 1 over sine t. On the top, you'd have negative sine t squared plus 1 over sine t. So negative sine t squared plus 1 is also another trig identity. So you can say that's going to be equal to cosine squared t over sine t. So you can ultimately say d of x over d of t is going to be equal to cosine squared t over sine t. And you would also have to find the derivative of the equation for y, which is a lot more simple than the equation for x. So derivative of sine t is just going to be cosine t. Pretty simple. Then you would have to plug it back into the equation. So I plug it into the equation. So I put in cosine squared t over sine t squared. And I'm doing the whole thing by the square root because that's the length equation given earlier to find the arc length. And then I'm going to do the same for cosine t, or derivative of y, basically. And then from here, what I do is I'm going to expand by carrying this exponent into the fraction, and then I get cosine 4t over sine 2t plus cosine squared t over 1. And from here, what I did was, once again, I wanted to add these two fractions similar how to I wanted to add them earlier. So I multiply cosine squared t over 1 by sine squared t. So this would get me, ultimately, cosine 4t plus sine 2t plus cosine 2t over sine 2t. That's just basically kind of basic fractions, but not too difficult. And then from here on, what you would want to do is you would want to have this cosine 2t factored out of that. So basically, you can say cosine 2t can be factored out of this full equation up here, and then you can see once again another trig identity, which is really cool. You have cosine squared t plus sine squared t, which is just going to be equal to 1. It's going to be the same trig identity that we used earlier for finding the derivative of x, but we're using it again just in a different way here. So from here on, what you would want to do is you would say cosine squared t times 1, because that's what our trig identity is, over sine 2t. So it's really easy because you see cosine over sine, which you can just say is cotangent. So you see, ultimately, you get cotangent squared over this, and the square root of that. So finding the integral of this, you can just say you're finding the absolute value of cotangent t. And from here, I plugged in our values for alpha and beta. I didn't want to write them for the whole thing, so I just plugged them in at the very end. And what's really interesting is this is going to be negative at a specific interval. So if you look at the unit circle, you can see that the values for cosine start to get negative on basically the second quadrant, the one at the top left. So what you want to do here is you want to separate this integral into two separate integrals. So you're going to have pi over 4 and then pi over 2 on your first integral, and then the integral, the range basically of where it's going to be negative is from pi over 4 to 3 pi over 4. So what I'm doing for that range of where it's going to be negative is I'm just going to multiply it by -1. So from here on, you would just find the antiderivative, and then you plug in your points. So I plugged in all of my points for the antiderivatives, and the antiderivative of cotangent is going to be natural log absolute value sine x, and that's just kind of another thing that went over in Calc 1 and Calc 2. So from here on out, I found out that this first portion is going to be equal to 1/2 times natural log 2. In the second portion, we're going to be subtracting. So I took this -1, put it on the outside of the derivative. So instead of adding these two derivatives together, we're subtracting them. So I'm just subtracting the negative, so I'm just adding it once. It's just a way of just adding those two together. So by adding those two together, I get also, for this section, 1/2 over 2, 1/2 natural log times 2. So basically the same thing as this, it's just double it. So by doing some basic algebra, you can find out the answer is going to be natural log 2, or roughly 0.693147. And that's the answer to number 6. Thank you.